Dear students, अस्सलाम वालेकुम। लास्ट डे हमने रेजिस्टिविटी रेजिस्टिविटी डिफाइन की। Last day we defined resistivity, and resistivity was defined as the resistance of a 1 meter cube of a material or substance. Mind you that we have to uh, clarify that it is the property of material. It is the property of material. Uh, Now, uh, last day, one or two terms we have to define. First term is conductance. Conductance is a reciprocal of resistance. What does this mean? This means that if the resistance, this expression makes the sense that if the resistance of a material increases, then it's it will be a poor conductor. What does this mean? This means that its conductance will be decreasing. So this there will be uh, inverse relationship between these. So uh, this is known as conductance. Similarly, we can define the conductivity of a material is equal to reciprocal of resistivity of. Resistance has the unit of ohm. So conductance will have the resistance 1 over ohm, means ohm inverse or ohm inverse, or sometimes we actually reverse the letters of the word ohm. Okay. And similarly, in case of conductance, the SI unit will be uh, ohm meter inverse. Ohm meter inverse. There may be some other names for the unit of these quantities as uh, humans are like that. But whatsoever will be the case, but for the present case, uh, we only this can also be written as no, because the reciprocal of ohm is MHO and meter inverse. It's like that. Sometimes it is also written as ohm inverse, meter inverse. The same. All these things are explained to you because they may be asked in case of uh, MCQs. and short section, and like that. Now we come to the temperature dependence of resistivity. Temperature dependence of resistivity. This temperature dependence of resistivity uh, can be explained. What does this mean? This means that we want to understand how the resistivity of a material depends upon temperature. What does this mean? This means that how the resistivity of a temperature of a material change with the of a material. I am always uh, whenever we will talk about the resistivity, we will always say that this is the property of a material, not a property uh, of a wire, not a property of a conductor. So, uh, in order to understand this, we know that the temperature increases, then the resistance also increases. The cause for this increase is that you should understand the cause. Whenever electrons flows to a conductor, then electrons actually scatter or collide. You can say collide with the pores. What are pores? Pore is something, for example, we have a material which has one valence electron. When this material, this with such atoms come close together and form the crystal of a material, then this electron, this outer electron of each atom become free. What we are left with? We are left with nucleus plus the electrons other than the uh, valence shell. This is called core. When current passes through the material to a conductor, the electrons collide with the core atom. Actually, this due to this collision, the energy is lost and a resistance to the flow of these electrons is offered. This resistance is called this opposition is called resistance, as we have talked the day before. Now, what happens when the temperature increases? Actually, at any temperature, these pores actually vibrate about their mean position. For example, this is the mean position of this pore, and they vibrate about the pores, about the mean position of this pore. This is the amplitude of vibration, amplitude of vibration. As we increase the temperature, actually this amplitude of vibration increases. So when temperature is low, an incoming electron which will scatter from this pore will pass through this region without altering its path But when temperature is increased, because this atom is now vibrating with this amplitude, and now if such electron will uh, try to pass uh, this particular atom, it will get scattered. It will suffer a collision with this atom. So this effect technically is called collision cross-section increases. So now we come to uh, we come to the explanation. As temperature increases, the collision cross-section increases. As a result, the number of reactions per cycle also increases, and the resistance per cycle increases. Since resistivity is the resistance of a meter cube of a substance, so with the increase of temperature, the resistivity of the material also increases. So this is actually the main theme of the understanding behind the behind the uh, reason for the increase of resistance of a material or resistivity of a material due to temperature. So now we want to describe some relationship between resistance and uh, resistance and the temperature of the material through a quantity called coefficient temperature coefficient of resistance. Now we want to define the temperature coefficient of resistance. Temperature coefficient of resistance. Temperature coefficient of resistance. Now I will try to explain how this temperature coefficient of resistance is defined. We have certain we have materials whose resistance increases linearly with the increase of temperature. Okay, me was talking that there are there is a certain range of material, a certain range of temperature. Over that range, the uh, resistance of the material is directly proportional to the temperature. There is a certain range of material, uh, a certain range of temperature over which the resistance of the material remain almost constant, mean increases linearly with the increase of temperature. This means that uh, e equal increase in temperature equally increase the resistance. This means the linear relationship or linearly increase of resistance with temperature. Okay, I think you have understood this. Suppose R naught is the resistance of material at 0 degrees C. Here, not 0 Kelvin. Okay. And R is the resistance at T degrees C. T mean any temperature, that is 5 degrees C, 10 degrees C, X, 100 degrees C, 500 degrees C, and like that, so on and so forth. Then, temperature coefficient of resistance, which is called alpha. Temperature coefficient of resistance, which is called alpha, is defined as the fractional increase in resistance. What is meant by fractional increase in resistance? Resistance at T degree minus resistance at 0 degree divided by resistance at 0 degree. This is called fractional change in resistance. Per unit increase in temperature, per Kelvin increase in temperature is called temperature coefficient of resistance. So in general, it is written as RT minus R naught over R naught into T. Mind it, here T is the change in temperature, that is T degree C minus 0 degree C. You can also write the corresponding temperature in Kelvin minus corresponding temperature corresponding to 0 degree C, that is 273 Kelvin. This can also be thought in those lines. This is called temperature coefficient of resistance. What is the unit of temperature coefficient of resistance? The unit of temperature coefficient resistance is Kelvin inverse. SI unit is Kelvin inverse. Okay, now we want to make the relationship of this resistance with the resistivity. We know that we know that we know that resistivity is proportional to the resistance with A over L. So resistance at 0 degree will be related to the resistivity at 0 degrees. This relation can also be obtained from the fact that R naught is equal to rho naught. Resistance at 0 degrees C is equal to resistivity at 0 degrees C into L over A. This is L. Similarly, resistance at T degrees C is equal to resistivity at T degrees C into L over A. Putting value in the above relation, let me number the above relation. For example, let me say it's 1. It is 1. Then alpha is equal to R naught. What is R naught? RT. What is RT? L over A minus, sorry, rho naught L over A divided by rho naught L over A into T, putting in 1. L over A is common. What we are left with, rho T minus rho naught over L over A common. What are left with, rho naught into T. This cancel out. So the temperature coefficient of resistance in terms of RT minus R naught over rho naught into T. So this is the temperature coefficient of resistance in terms of resistivity. You should learn and remember these two relations. First relation is temperature coefficient of resistance in terms of resistance, and second is the temperature coefficient of resistance in terms of resistivity. Now, in your book, there is a table of temperature coefficient, and let me show you the table, and also the concept of the variation of resistance with the temperature. Let me show you with the help of an picture. This is the picture, which I have told you that there are compounds whose resistance or resistivity increase or decrease linearly with the certain range of temperature about 0 degrees C. For example, this is the 0 degrees C. This the resistance or resistivity of this material is linearly increases or decreases with the temperature from minus 200 degrees centigrade to almost uh, 500 degrees. So this is the basic concept due to which we we define the temperature coefficient of resistance. And I have explained to you that how temperature coefficient of resistance is defined and explained. Here is the table of different substances. For example, silver, 1.52 into 10 raised power minus 8, and temperature coefficient of resistance is 0.0380, 0.390, 0.340, 390, 460. What does this mean? There is a major difference. What does this difference mean? This difference means per degree Kelvin, per degree C increase in temperature increases the 0.00460 ohm resistance of the tungsten. But in case of silver, it is increased by 380, and so on, so forth. So there are some compounds for the negative temperature coefficient of resistance. This is also the also an important concept for the case of materials which have negative temperature coefficient of resistance. What is meant by this? This means that this factor will give the negative answer. And it is possible that if we have a material whose resistance decreases when we increase the temperature from 0 degrees C. Okay, such material are called material with negative temperature coefficient of resistance. Tomorrow we will have some important application of such materials which have negative temperature coefficient resistance. That is, and examples, always keep in mind the example of such compounds. They can be asked in case of MCQs. So germanium 0.05 and silicon is 0.07. Okay, students, it's going to be to end. We will talk about the day next day, inshallah.